So thank you, everyone. Going to cover a lot of the technology today are very abstract. So going to take the opportunity to talk about something very real, which is fraud and how to prevent fraud with our platform. So a lot of the times when you look at big data platform, one of the things you struggle with is what is the time to market. So for most of our clients, they derive value from our platform in less than 4 weeks. It's a one API. One of our clients says that it takes 10 minutes to integrate. So hopefully this talk will interest you. So we're based in the Silicon Valley. So we're bilingual. So since we're speaking at the international forum, I'm taking the opportunity to use English, which is a language I'm more comfortable with. We're founded in 2013. And our specialty is using something that's called unsupervised machine learning to uncover attacks before any damage is conducted. So we have a very elite team. Our founders are top researchers from Microsoft. And our team actually consists of 60% of us are PhDs from CMU, Berkeley, Stanford, et cetera, et cetera. So thank you for the opportunity to speak on this forum. Alibaba is not only a partner of us, we leverage the Alibaba Cloud. Alibaba is also a customer of ours, leverage our technology. And from worldwide, we actually cover over 2 billion users globally. We have processed over 600 billion events to date and have detected over 130 million bad users to date. So why fraud is important? And a lot of times when I speak, it's important to see the size of the problem. So if you look at it, in 2015, fraud itself, it's cost the world economy $3 trillion. And by 2021, it's $6 trillion. You say, well, $6 trillion sounds like a nice chunk of change for Jack Ma. But just looking at the GDP for China last year, the GDP for China is $21 trillion, and for the US is $18 trillion. So imagine like 1 out of $4 that are produced in the Chinese economy, actually if you're paying for fraud, it actually covers what the fraud damage is in the world. And then every second, 12 people are a victim of fraud, and over 1 million victims a day. And 75% of the Fortune 500 companies, when they're talking about their existing system, it takes, 146 days on average to detect the issue with the traditional means, and then actually to plug the hole. So during that 146, you can see a lot of damage. And then by 2020, over 25% of the attacks will be actually based on IoT. And you know, like a lot of people talk about IoT, these devices are actually very vulnerable to attacks. So the attack surface will actually more than double to 21 billion by 2020. So you'll see that not only your system had to, it actually had to sustain more volume in attacks. So if you look at also some of the trends for fraud, right now, you know, like for a lot of credit cards, we added the chip. So what happened, physical fraud actually has gone down. So that means that online fraud is on the increase. In large-scale breaches like Equifax breach as well as a Yahoo breach with 3 billion users means that large-scale traditional means of like validating your personal identifiable information as part of the validation is no longer going to work because all this stuff is on a database somewhere and people already know you and you have to use other form of technology to protect your customer. And then if you look at the typical fraudster, they're actually more a developer. So not only they're using the cloud, they actually use proxies and VPN, and they use emulators and mobile device flashing. So it's extremely hard to catch. And also they're actually using AI. So the attacks are actually adaptive. So not really solely, and they actually will not just repeat. They will actually learn along the way. So if you look at the attacks, they're actually diverse and coordinated. So if you try to catch a crime ring, it actually has multiple layers of distinction, and then they actually conduct all sorts of the damage from account opening, identity theft, to money laundering, and so it causes a lot of brand damage when corporations are exposed to these forms of attacks. So if you look at fraud fighting tools, we start with the real basic reputation list. How many people think antivirus work? Actually, over a decade, it's based on reputation list. Actually, it didn't work anymore. So if you install antivirus, most of the time you're just slowing your computer down. It doesn't really do much for you. Rules engine is what most companies use today. It takes a lot of people to look at the form attack and actually generate the rules. And then there's forms of machine learning. One form is called supervised machine learning, where you have to have large amount of data and you know if the people are good or bad in order to make disposition, create the model to analyze a user. And what we do is we use unsupervised machine learning, which is actually self-learning type of technique to actually propagate and actually auto-generate all forms of protection that we listed below. So let's actually, maybe not everyone's familiar with all 4 forms of this, so I'll cover it very quickly. So first of all, reputation list. It's very simple. You look it up, there's a table. It's good or bad based on IP address, emails, whatever you can think. You can buy these data sources. These could be refreshed, and you make decision based on these lists. Rules engine, it's basically back end, and you can think about it, it's human comprehensible form of rules. It's auditable, it's easy to understand. So what will happen is the operation team will look at what fraud is conducted against the company, then they create rules to protect yourself. So the rule system works really simply. So you list the rules, and then you create a scoring system, and use this scoring system to determine if a user is good or bad. And then it also, some of the more complex system allows you to use code inside the rules. And then there's a form of supervised machine learning. So what you do is it's a black box. There's already canned algorithm that works. So what you do is you take known data of good users and bad users and use it to train a model. And then you push the model to disposition if a user is good or bad. And what happens is new data comes in, new labels come in, you update and refresh your model. So what we do in Datavisor is that we leverage something called unsupervised machine learning. So what it is looking for clusters of similar activity. But instead of thinking about it in one dimension, which is actually generated and looked on this graph, we actually look at thousands of dimensions. I'll give you actually real use cases of this. So why is unsupervised hard? Because it sounds really simple. So it does clustering, and you actually have to look and analyze relation to each other. So you actually have to do both form analysis of clustering plus graph. So our specialty is actually accelerating both of these techniques, and we have 7 patents files against those, so that we can actually do this dispositions real time with large data sets. So how it works is that in very high level abstraction, good users, their activities are very random in nature. So even if you look at thousands of dimensions, as we call features, they're actually not very correlated. But bad users, they're very correlated in data. So I can give you a real example. So if a fraudster obtained PI information from a data breach, they apply it to an account. When you look through it, it's really hard to actually find exactly what the correlations are. So if you scan through the list, everybody has a unique IP. It looks like these group of users all use different email providers, so they look like a very same group. But then when you actually add additional dimensions to it, like what I said, you actually find that all these people are actually come from the same ISP, and actually all of them are actually using an application the same way. This is a financial application. They're actually performing the same transaction against Chase. Then you find what we call the fraud rings, and these are what we call correlated attacks. So what we do is I'll actually share some of the technique and our experience on cloud computing later. But what we've done is that we actually have a 50x efficiency in computation against brute force, and also 10x accuracy with our clustering prediction specialization. So if you look at the comparison between the approaches, why unsupervised machine learning matters is that reputation list is limited in coverage and precision. It's actually really hard to understand when it's real. And then once people learn what they are and they know the yes or no answers, they actually can work against it. So they can block attacker one time, but then in the future, they don't block it because people can circumvent the rules. And then rules engine, the issue of it is actually maintenance of the rules, and the rules need to adapt constantly. So if you rely on a human to actually look at the rules and maintain the rules, when it gets to thousands of rules, what you'll find is a symptom is that these rules actually always stay. You never take rules out, and it gets more complex over time. So you never know like if a rule is effective in blocking, but you're just there for legacy reasons. With supervised machine learning, one of the challenges for companies is that you need a large amount of label data where you know if a user is good or bad in order to train the model. Most people don't have that. And in order to, if you don't have that, then it's really difficult to create an accurate model to detect unknown attack. So with supervised machine learning, because we look through all of these dimensions, what happens is that we can generate labels automatically, and we can detect attacks when they morph over time. And also the rules, we actually have our own rules engine. We can auto-generate the rules to plug some of the holes that exist with the other techniques. So how does it work? So let's talk technology a little bit. So what we do is we build on top of Apache Spark. So a lot of the data analysis we run in near real time in batch manner for unsupervised and supervised mode. So when we generate the data, we actually use unsupervised machine learning to generate the training data for supervised machine learning so that the model is actually auto-generated. We extract for billions of users, trillions of features, and look for correlation. Once we understand what some of the correlations are, we have a real-time system that we built from the ground up that uses a simplified rule set to look at people in fraction of a millisecond regarding if they're good or bad, and actually return a confidence score regarding the disposition. So we also do something we call the Datavisor intelligence network. So the concept is really simple. So we use deep learning to do this, where we take everything we aggregated thus far, and then we actually create a deep learning model to in theory, block people or block attacks. Once an attack happens to one of our clients, actually everybody else is protected by from this type of attack by leveraging telemetry that is generated across the world. So this is a typical fraudster attack cycle. So it's very typical to software development. They first test to find out thresholds and limits, and once they understand what they are, they create accounts behind the scenes to age the account. And once the account's there, a lot of the rules are based on how fresh the account is created, because what generally people think that the fresher it is more prone to be hackers. Actually, hackers are smart. They know how to incubate, let it sit over there, age it like wine. And then they actually formulate attack in a very short span of time because they know they have 100-something days of time to reap damage and control. So our algorithm actually create alerts between testing and incubation, because we can actually generate signals from the IPs, etc., and understand what the fraud behaviors are and help people block it before the attacks happen. So, so we also have behind the scenes very graphical disposition. So it will tell you reasons why these users are bad, time series of what type of attacks, when did it happen, and when did it stop, and also quantity attacks and also cluster analysis to help you to generate patterns associated with attacks. So our automated rules engine, what we did was that we actually built a system that rules are automatically generated within our unsupervised machine learning. We also allow our customers to generate manual rules to augment the system. But what we do with the automated rules is that we backtest with the data that we store to understand the effectiveness of the rule. So we auto-deprecate the old rules so that you don't have to manage those. As we create new ones, we also take ones away that are not effective. So on the cloud, we're going to talk about a couple of tips, because when you look at all the things that we do, there's quite a few data computational challenges. So we share some of our learnings because we operate on it for over 3 years. One of the things we have to do is to have a very globally distributed data center. So we do multi-regional. Not only that, we did multi-cloud. So we partner not only with Alibaba Cloud, we also partner with Amazon. So on Amazon, 80% of our instances are spot instances. As you know, like spot instances, they're a bid-based system. So we automatically bid for cheap servers to do the computation to get the pricing advantage. And when we at peak, we actually run with thousands of instances to make sure that the results are generated not only fast, and actually is generated near real time to help protection. If we look at it from an Alibaba Cloud perspective, one of the things that we found is that they have way more better customer care with personal touch for us. When we ran into issue, there were tremendous support that helped us to overcome the issue. And really we appreciated AWS, we didn't experience that for sure. And then in China, one of the challenges of running AWS in China is that we only do Beijing, but because there's no spot instances, we found that Amazon is actually many times more expensive than Ali Cloud. And so from a cost perspective and also network connectivity perspective, Ali Cloud is vastly superior to AWS. So another tip that I would like to do is that when people look at Spark, they also look at the entire Hadoop stack. That's something that we believe is not the right way to go. We actually run it without Hadoop or HDFS. We run it directly on OSS. There's a cost advantage in doing it because running your own HDF instances, you have to build to utilization. So it's really hard to scale up and down on storage. So if you use OSS, that auto scaling and that vast sheer capacity actually gives you about a 4x saving. The reliability of it is much higher than your own HDFS instances. With our own experience, we actually experience way less than a 99.9% uptime for our own HDFS cluster. So we find that using something that's highly durable and also reliable is extremely saves you a lot of time. Another thing that we do, and this is something again sharing the best practices with fellow technologists here, is that we currently process over 10 gigs of data per day. So about each one of the customer, for average peak for the customer is 5,000 queries per second. So it's very large data volume when you try to process it real time. So what we do is that we not only run the batch process multiple times a day, we also try to do it in a pipeline pattern. So we don't have a large job. We actually take advantage of the fact that you can break it up and run things in parallel and use a pipeline pattern. We also scale to actually help with time and execution. So certain tasks with a lot of data will take time. So what we do is we set up additional instances so that it can be computed in a timely manner. So there are some useful cases that I would like to share. So with our customers and vast variety of use cases or what they ask us to help with, we actually stop fake account creation. We also stop transaction fraud. So with our partners, we typically find that we save them between 30 to 50 cents more than traditional solutions that have implemented. That's our experience. Also, I just mentioned that account takeover is a real problem. So there's a lot more clients asking us to help them with account takeover. Fake reviews and likes, we have Ting and also Yelp and then Pinterest. So we help with content, fraudulent content. Filter spam, and also fake app installs. So for mobile installs, we actually save typically between 5 to 10% of your whole marketing budget by finding fraudulent installs so you can get a rebate from the ad networks. So let's go through some case studies. I want to show you something that as we talk about different features that we learned, you can learn as best practices. So what we learned is that typically if the traffic is from a cloud platform, apologize to Alibaba Cloud, that is typically fraudulent, but only about between 20 to 45%. We also anonymize the cloud provider to protect everyone's identity. So some of the bad providers, you'll find 23% of their traffic is fraud. For some of the better providers, they're actually in a single-digit percentage. And it also varies by time, the amount of fraudulent providers. So what we found is that attackers or fraudsters move from cloud provider to cloud provider to actually anonymize their identity. So it's very hard to actually have a fixed rule that helps you block everyone. Also, what we found is a trend. This is a picture of what's called a click farm. So you have a person there that's typically this happens with mobile gaming because the CPI is extremely high, anywhere between $10 to $100 CPI. So it's actually very profitable to have somebody manually play the game or play the application, and it's really extremely hard to detect. And what we found is typically because these click farms has a investment there to buy the devices, fraudulent traffic is usually shifts that the devices are older proportionally to something that's actually real and organic. So that actually helps us identify some of the sources. And then actually iPhone 5, 5C, and 5S are the most popular because I think it is extremely cheap to buy these used on the internet. What we also do is that this is actually a real case of wire transfer fraud. So when you look at it, rules-based system will have a very hard time catching this because all of these are right below the threshold. As I talk about, like rules are created with hard thresholds. For real systems with rules, this client of ours has a rule where they don't check. We're running any checks for anything below $3,000. So they discovered this and we're able, and then with our system, we're able to detect this fraudster ring because they seemingly send to different but correlated receivers, and because the fraudster actually made a mistake where all of these receivers actually live around the same area. So that was actually one of the dimensions we found with this fraudster ring. And then P2P payments. Also, we find like people use rule-based system trying to stop this, and it's not very effective. So these actually go right below $500. There's a rule for $500. As you can see, the fraudsters were actually testing, and most of the attacks are conducted a little bit below $500. And then similar to previous examples, we found overlapping recipients, similar IPs, and similar devices as typical forms of attacks. This one's very interesting. This is another feature that we have in our system. When we have a mobile app and somebody is actually using sequential transactions or actions within the mobile app, this one actually teleported, so within a span of a few minutes, they actually teleported within different regions in China. And one of them is a really large region, a real large jump, which is not humanly possible. So this is something that's fairly evident that this is not real traffic. So, well, thank you a lot for the opportunity to speak here. If you guys would like to learn more, we have a booth in Exhibit D, the areas D. So thank you for your time.